Now the second half of 11.3 is very similar to the first half, but we're going to build on it a little bit. So can someone in your own words explain what mutually exclusive means? Riley? Correct. So two things or events that cannot happen at the same time is mutually exclusive, excluded, or separate. What's the opposite of that? Something like inclusive or not mutually exclusive, right? Like two things or two events or situations that could happen at the same time. For example, if you're rolling dice, you could roll a 3 or what? Like a multiple of 3 would be 6, or even would fall in the same category. A multiple of 3 or even would be two of the same thing, so it's not mutually exclusive. What we're going to do now is find the probability of mutually exclusive events. So in letter D, what you're going to do is first make a decision about whether they're mutually exclusive or not. If you decide that two events are mutually exclusive, it's pretty basic because you just add them together. But if they're not mutually exclusive, there's something else to do. So the first thing where this bullet point is that's blank, we're going to write the definition of events that are not mutually exclusive. So the probability of event A or event B happening, if they're not mutually exclusive, is finding the probability of A, adding it to the probability of B, but then you have to subtract whatever the overlap is, whatever the commonalities are. So you're subtracting the probability of A and B. This, I like to call this the overlap or the commonalities, whatever it is they have in common. If they are mutually exclusive, it's very basic. You just would do the probability of A or B happening is whatever the probability of A is added to the probability of B. Just add them together. Sahil. This is whatever A is. This is whatever B is, two separate things. And then the overlap would be whatever they would have in common. So like the problem about rolling a dice, like rolling a die or two dice, which multiple of 3 is also even on a die? So you'd have to subtract the probability of a 6, like the thing that is included in both categories. So for example, number 1 says at TKA, and I made this up, guys, I don't know if this is true, a student can take one foreign language each term. About 37% of the students take Spanish, about 15% of the students take Latin. What is the probability that a student chosen at random is taking Spanish or Latin? First of all, is this mutually exclusive, or is there some overlap going on and it's not mutually exclusive? It's mutually exclusive based on this word problem, right? So let's write that first. This is our decision that we made before we started. So in my little abbreviations, the probability of event A or event B, Spanish being A, Latin being B, just because it was mentioned second, would be the probability of the first one added to the probability of the second one. Now, they already told us it's 37% of the students. We don't even know how many students there are total. They gave us the percentage already. So you're really just doing 37% plus the probability of the second thing. What was that? 15%, and you're just adding them together. 52% of the students take Spanish or Latin. Or you could say it like the probability of a student chosen at random taking Spanish or Latin is 52%. It could be worded in either way. The answer is just 52%, honestly. Okay, perfect. And welcome, by the way. We just started in 11.3. All All right, if 9% of the students take Mandarin Chinese, what is the probability that a student chosen at random is taking one of the three? So it is just 61. It sounds harder than it is when the probability is already given to you, right? Like you're just adding these together and that's it. So it's the 37 plus the 15 plus the 9, which is 61%. I think Kings actually did used to teach a Mandarin Chinese class. Kindergarten. Really? I thought it was like high school class. Like actual. I don't think they do now, but I thought it was actual. I heard. All right, without knowing the number of students at the King's Academy, can you determine which language most students take? So, yes or no? Why would you say no? Uh-huh. True, but the question isn't necessarily what they're doing, is can you determine which language most students take? Yeah. So it doesn't matter how many kids there are, you just yes, because the percentage of whatever the total is given, and 61, is the most. Or like 37, whichever percentage they're giving you, they give you that number, that percent. So the answer is yes. Percentages are great. They're always based out of 100. It gives you an idea of what's most or not most, or if something's right in the middle, regardless of how many students there are total. So you can rephrase this if you want. Right. If it asked which one, you'd be like, well, it's Spanish because that was the highest percent. Mhm. Oh, I see what you're saying. I think this question's more ambiguous than that. It's just a matter of like that you don't need to know the number of kids, that a percentage would just make it out of 100 and you could answer that. You could say yes. You could make that determination, whatever it is. This is a vague question. It's more ambiguous.
What language most students take?
Could you, you're saying?
Yeah, well, don't you have to?
No.
No?
It's just asking if it's possible. Could you determine that?
At the top of that page,
Uh-huh.
you said like it's not mutually exclusive if P is A and B, you have to do that whole equation.
Yeah.
Well, on the other page, isn't it just P is A and B times A and B?
That is when you have two things occurring at the same time. Like what I want is like the 5 people flipping 5 different coins. What's the probability of all of them, their coins landing on heads? That was like 5 things all at the same time.
This is like,
And let's look at one like that on the next page. Now we're going to do one. That's not the same scenario. Not yet. That's this next page. So when 2 events are not mutually exclusive, what you're doing is subtracting the common outcome. So the probability of A or B, 2 events that are actually not mutually exclusive, you would figure out them separately, add them together, and then subtract whatever the commonality is. The key word is or here. I think we did this the other day, didn't we? And means multiply. Or means add in the land of probability, right? So you're asking about this. Are we multiplying something there?
no, at the beginning, at the top of the next and. Oh, no, I just missed it.
Okay, gotcha. All right, good. I was like, wait a minute. I don't want to confuse you in my definitions. All right, I'm glad I wrote it right. Perfect. Okay, so a dish holds 9 items. 1 yellow triangle, 2 orange squares, 1 green square, 2 green circles, 2 red circles, 1 orange circle. Can you picture this? It's like toys. Like you've got a dish with these little blocks or something, like it's toys. Suppose you reach into the dish, you're not looking. You select an item at random. What's the probability that it is round or green? Sahil, what do you think? You're going to be subtracting something. And I know I read that really fast. So 1 yellow triangle, 2 orange squares, 1 green square, 2 green circles, 2 red circles. So we need to know how many items in this dish are round. Well, the triangle is not round, right? Which item is round? All the circles are round, right? And then you need to figure out how many green items there are. Okay, so first things first, are there any that are both round and green? Yes, so these are not mutually exclusive. There is some overlap in these categories. So that's the decision to first make, that you know these are not mutually exclusive events. Some items are in both categories. So what I'm doing is finding the probability of choosing an item that is round, I'm going to say R, or green, and so I'm going to say G for green. It's kind of like using an abbreviation so I don't have to write everything each time. But then, so my little formula would be like probability of getting a round item plus the probability of getting a green item minus the probability of any round green items, any that are both. Does that make sense so far? So now I have to go back and I'm picturing this little dish and I have to imagine I'm counting up the items that are round. How many round ones are there? 5. So the probability of getting a round item is 5 out of 9 because probability is desired outcome over total, 5 over 9. How many are green? So 3 out of 9 is the probability that when you reach in there, you're going to get a green one. And now I have to subtract the round green ones. Reese, you said it a minute ago. How many are that round and green? 2. So you're subtracting 2/9. Yes, because some of them are green squares, green, whatever in total. Like this is all rounds. This was all greens. This was green rounds, right?
So I've been really using the squares at all. One green square instead of 2 orange squares on the other.
Right, exactly. And a lot of times in these problems, there's extra information. You just have to ignore it. It's like, what am I actually focusing on in this problem? So isn't it 6 over 9? What's that, like 0.6? Right, so like 67% if you round it. 6 over 9 is 0.6 repeating in the calculator, so about 67%. Yes, ma'am.
Would you rather us do like add up with the fractions and then subtract it, or all in fractions, or can we do to find out the percentages and then do it like that?
Either way is fine. I will say though, your answer is usually more accurate if you leave them as fractions till the very end, because then you're not doing any rounding till the very end. Questions on the SAT, it's multiple choice, and so if they're all really close together, you may want to wait to do any rounding till the very end. All right, you select an item from the dish above. What is each probability? The item is square or red. So the first question is, are these mutually exclusive? Are there any red squares? So are they mutually exclusive? Yes. There's no overlap. So I'm just doing the basic, which is adding together probability of getting a square item. How many is that? There's 3 of them, right? How many reds? 2. So the probability of choosing a square or a red would be 3/9 plus 2/9. What's that? Yeah, so 5/9 is what, 56%-ish? You can round it to a whole number, that's fine. All right, what about the item is green or square? Mutually exclusive or not mutually exclusive? Why not, Jonathan? Exactly. There's something that falls into both. Spell, let me get this right. Not mutually exclusive. All right, so the probability of getting green, how many is that? 3/9, that's just your plain old green ones, all of them. Plus, how many squares in total? 3. Minus how many are both green and square? Only 1, so you minus the 1/9, which would be 5/9 again, so that's your 56%. Now, on this poster that I made from a terrible deck of cards we had at my house, this only took me like a few minutes to make, by the way. This is another good example of when you can do these. Like, what's the probability of being dealt a hand that has certain cards or certain things? And so you see a lot of overlap with cards. It may say something like, what's the probability of choosing a face card? How many face cards are there total? 12 out of how many? 52, so you do 12 out of 52. But what if it said something like, what's the probability of choosing like a red face card or a red or a face card? Well, you've got some that are red face cards, so you'd have to subtract the overlap. But that's where this comes in handy to make it visual, because a die only has 6 sides. That's a little easier to picture in your mind, but there's 52 cards and many different ways this could work. So that'll be there for you if you need it, if we have a card problem. All right, any other questions or anything? You now have enough information to finish your homework. So this page that you got yesterday, 11.3, that's your homework for tonight. We're just going to do the rest of class finishing that. And that's it. What are we doing tomorrow? Tomorrow is classwork and a quiz. We're going to practice the classwork first, take the quiz the second half. Good job.